Hey everyone, welcome back to Take You Forward. Today we will be solving an interesting problem on partition DP, which is minimum cost to cut the stick. Now, what does the problem state? The problem state you'll be given a cut array and you'll be given a length of the stick. Now, what do you mean by a length of the stick? This is a stick of length 7. Now, if we just write them down, this is how the stick looks like. Okay, this is a stick of exactly length 7, and this is first 2 3 4 5 6 7, so a length of 6 7. Now they're asking you to cut these at these portions. You can cut it at 1, you can cut it at 3, you can cut it at 4, you can cut it at 5. You can cut it as you wish. Okay, and you have to find me the minimum cost. Very important, you have to find me the minimal cost to cut the stick. Okay, now you can follow any order. So what is cost? Cost is the length of the stick you're cutting. Length of the stick you are cutting. Okay, so if I start by cutting at 1, what is the initial length of the stick? If you just write down the length of the stick, it's 7. So if I decide to cut at 1, the initial length of the stick is 7, so I do a cut at 1. So if I'm doing a cut at 1, I will have a stick of length 1, and I also have a stick of length 6. Okay, this is 1 2 3 4 5 6 7, a length 6. Now if I decide to cut a length 3, where is length 3? Length 3 is here, which is saying this. So what is the length of this stick? Because this stick is no more connected to this. What's the length of the stick? 6. So you'll require a cost of 6 now, and you decide to cut it here at 3. So now you will have a stick of length 1, a stick of length 2, and a stick of length, right, starting from 3 4 5 6 7, a length 4 stick. So now I say cut it at length 4. Where is length 4? This is 4. So what's the length of this particular stick? 4. So the costing that you'll require is 4. Now I decide that I'm going to make a cut here. So if I decide to make a cut here, I will have 0 1, I will have 1 2 3, I will have I will have 3 4, which is length 1, and I will have 5 6 7, which is somewhere around length 3. Perfect. So just write it properly. My bad. Let me write this properly. We will have 4 5 6 7. Yeah. So it will be of length 3. Next, I say cut it at 5. So if I'm cutting at 5, which is this, and this stick length is of 3, so I'll be requiring a cost of 3, and I'll cut it here, and I will have a stick of length 1, I will have a stick of length 3, I'll have a stick of length 1, I'll have a stick of length 1, and I'll have a stick of length 2. So this, when you cut at 5, was of length 3. So the total costing that you will require is 7 plus 6, 13 plus 4, 17 plus 3 equal to 20. This is the costing you required if you went on by cutting it at 1, 3, 4, 5. The cost came out to be 20. The question states you have to minimize this 20. I don't want 20 because it's a lot. I want to minimize it. So the question states minimize the cost. Okay. So what we will do is we will go across by minimizing it. So you can follow the cuts in any order. So in this case, if I cut it like 3, 5, 1, 4, like it was given to us as 1, 3, 4, 5, but I rearrange the cuts to say I'll first do a cut on 3, then I'll do a cut on 5, then I'll do a cut on 1, then I'll do a cut on 4. Okay, so okay, fine. So that means initially we had something like, let's quickly write this off. Initially we had a length 7. So just write this off. We had a length 7. Perfect. And the so if I'm making a cut at 3, which is this portion, it is initially of length 7. So 7 will be added. Now we will have a length 3. Goes like 0, 1, 2, 3. We will also have a length 4. Goes like 3, 4, 5, 6, 7. Perfect. Length 4. I'm saying cut at 5, which is, I'm saying cut it over here. So this stick is of length 4. So answer added will be, the cost added will be 4. So after this, we will again have this 0, 1, 2, 3. right? We will again have 3 4 5. We will again have 5 6 7. Perfect. So we have made sure that we have done the cut at 5. I'm saying cut it at 1. So if I'm cutting at 1, which is this is a length 3 stick. There's a length 3 stick which I'm cutting. So the costing will be this. So I'll be left out with 0 1. I'll be left out with 1 2 3, which is of length 2. I'll be of 3 4 5, which is again of length 2. I'll be of 5 6 7, which is again of length 2. So the costing is 3. Next I'm saying cut it at 4. So if I'm cutting at 4, which is definitely this is a length 2 stick. It's length 2 stick. So the total cost that comes up is 7 plus 4 11 plus 3 14 plus 2 16. So I got a lower cost. You can try out all orders, and you see if you follow the order of 3 5 1 4, this is the lowest cost that you'll get, which is of 16. Yes, this is the lowest that you'll get, is of length 16. You can't go lower than this. Okay. So before moving to the solution of this question, let me tell you about the sponsor of this video, which is Hirect. Now, this is the time of the year where you expect appraisals, right? Now, is appraisals all about salary hikes? Definitely not. Now, when you're looking out for an appraisal, you mean that you're valued, you're promoted, you're given much more opportunities, much more freedom to do a work. But when all of these doesn't happen, that is when you start looking for a job switch or career hike karke to dekho. So that is where something like startups come in, because with startups you get a lot of liberty to work, a lot of salary hikes. And how do you find startups? Obviously, in order to find startups, you can download Hirect. Yes, Hirect is India's first hiring app, which allows you to directly consult with CEOs and founders of the startups. At Hirect, we have over 1,20,000 plus startups which are hiring. Now, what do you need to do? You don't need to do anything special. There's a link in the description. You need to download the Hirect app. Once you've downloaded the Hirect app, you have to fill up all this relevant information about yourself. And once you've filled it up, the Hirect app's algorithm makes sure that you're connected to relevant job profiles. And yes, one more thing, there is no consultancy involved in between. You are directly chatting with the co-founders or the founders or the CEOs of the startups, and you can directly ask them whatever you have in mind. And also, your data will be staying private. Without your permission, it will not be shared anywhere. So what are you waiting for? There's a link in the description. Go and download Hirect and just look for a switch. So how do you approach this problem? Because you will be given something like 1 3 4 5, like this is in cuts. You'll be given the length of the stick. So how do you start approaching? Because you can either start with 1 as the cut, you can either start with 3 as the cut, you can either start with 5 as the cut. So you have a lot of options to start with. So can I treat this as a complete stuff? Can I treat this as 1 3 4 5 as a complete stuff? I can. And then can I say, if I make a cut at 4, if I'm making a cut at 4 for sure, I can also start with 5. Or I can say I can also start with 3. So I know if I treat this as a partition, like if I treat this as an I and j, like an entire array, I can say I can either start with 1, I can either start with 3, I can either start with 4, I can either start with 5. So what if I start with 4? I know the initial length of the stick. Is 7. So I'll add up 7 to the answer. How we will find this, we will get to know. But if I start with 4 for an example, I say I'll make the first cut at 4. Can I say if I'm making the first cut at 4, the answer that I'll add is 7, because that is the initial length of the stick. At least at the first step, the length will be the complete stick. So can I say now I'm solving only these cuts and only these cuts. I'm solving only these cuts, right? Like a 1 3 and a 5. I'm just solving these cuts. Now, if I solve them independently, will this work? Yes. Why? Because it is sorted. Let's understand what does this mean. Now, if you have made a cut at 4, you know that you have something like 0, 1, 2, 3, 4 now. And you also know you have something like 4, 5, 6, 7, because you have made a cut at 4. So you've segregated them. No matter if you perform 5 at first or 3 at first, they won't matter, because even if you're performing 5, it's nowhere connected to the stick. Even if you're performing the cut at 1 and 3, it's nowhere connected to the stick. The sticks have been separated. The sticks have been separated. And why can you solve this sub problem independently, and why can you solve this sub problem independently? Because they are not connected. But if I just do one thing, I just do one shuttle change, and I say I'll just change this test case to this, and imagine I was having something like this, and the writer sub problem would have been 5 comma 2. Imagine this was the right sub problem and this was the left sub problem. Now you cannot solve them independently, because this is dependent on this, because this two, the 2 on the right will be over here. So you're dependent on the left stick. Thereby, it's very important to have it sorted, so that whenever you solve a problem, sub problem, they will not be dependent. They will not be dependent. You can just go over and see whether you want to make a cut at 4 or 5. You won't be dependent on this. You don't have to decide whether you want to make a cut at 1, 3, then 2, or at 1, 2, then 3. You will not be dependent. So it's very important that you make sure that the array is sorted. Okay, that is something which you have to do. Now, how do you find the length of the sticks? Very important. So let me just visualize it again. I'm having 1, 3, 4, 5. Okay, I know this is a partition that I'm solving. This is a partition that I'm solving. Okay, this is an entire partition that I'm looking to solve. I want to find how are these cuts going to give me the minimal cost. I'll just put in a 0 and the length of the stick right at the left and right at the. I'll just put a 0 on the left and I'll just put the length of the stick on the right. Why do I do this? You'll understand. Imagine I'm making a cut at 4. I know I can make a cut at 3 or at 5 or at 1 anyway. Imagine I'm making a cut at 4. I'm making a cut at 4. But what is the cost? The cost is the length of that stick. Length of that stick in which 4 is. In which 4 is. The cost is the length of that stick in which 4 is. That is for sure. How do I get the cost? I minus 1 cuts of j plus 1 rather, which is this j plus 1, minus cuts of I minus 1, which is this. 7 minus 0 is 7. This is the length of the stick. This is the length of the stick. If I apply this formula, it'll give me the length of the stick. I will show you why in future. So we have understood that this is giving me the length of the stick. Now if I'm taking this guy as the first cut, then I need to solve this guy. So imagine this is at index. I need to solve this portion, this sub problem, which is I to index minus 1. And I need to solve the writer sub problem, which is index plus 1 from the right to the last. Because I did a partition on index, I solve it from I to index minus 1, this smaller partition, and index plus 1 to j, this partition. So I just took an cut and I'll be solving these couple. And since they are sorted, they are independent. And since they are independent, I can just solve them independently and add up the answer with the current answer, which is this. Now you might ask, how is this working? I'll show you after I write the code how is this exactly working. You'll get a clear-cut idea, but before that, let's start writing the code. So you've understood that it's going to be a partition, like 1, 3, 5, 8 was initially given to you. You will just 1, 3, 4, 5 was given to you. You will insert a 0 at the front. You'll insert a length of the stick at the back, and you'll if I write down the indexing, it will be like 0, 1, 2, 3, 4, 5. So I'll start off I from here and j from here, which you can call it as f of 1, comma whatever was the initial length, like whatever is this initial length was 4, right? Initial length was 4, so you can just start off with 4. So that's what the initial partition will start off with. So f of 1 I comma j. Now I know I can start with this, 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 which eventually means I can take anyone as the first guy. Anyone as the first cut. I can take anyone as the first cut. So thereby, what I say is, okay, now in partition DP, if because you are solving a portion, if it crosses over, there is nothing to solve. So you can just return a 0. The cost will be 0 if there is no partition to be solved. I know one thing for sure. I can take anyone from I to j. And when I'm taking anyone, the costing that I'll incur is cuts of j plus 1. I've already showed you why, and I'll prove it again. This is the this is the cost if I cut it at that index. And I have to solve the left guy, which is I of index minus 1. I have to solve the right guy, which is index plus 1 comma j, for sure. The left guy and the right guy is what I need to solve. Perfect. And since I need the minimal cost, probably I can keep it as int max, and I can just say minimal equal to minimal of mini comma cost, and at the end of the day I can just return the mini and I should be done. This is how the simple enough code looks like. What I do is I take the current cut at any of the index, and then I go to the left subproblem, to the right subproblem, get it for every index, I get the cost and take the minimal of all the indexes, and that is what I return. So I try all partitions and I return the partition that gives me the minimal answer. Okay, now coming back to this portion, which a lot of you probably did not understand. So let's take a bigger example just to make it clear enough. Okay, imagine this is the stick and the length is somewhere around 12. Imagine the length is somewhere around 12 and you are starting off by solving this portion of partition. Okay, so just for an example, imagine the first cut that you made was at 5. The first cut that you made was at 5. Or for that reason, the first cut that you made was at 3. So we're making a cut at 3. The length is definitely, because this is I and this is j, the length is definitely 12 minus 0. So j plus 1 and I minus 1 for sure. That is for sure. But whenever you're making cut at 3, you are having a subproblem as 1, 2. This is your subproblem. And the right of it as the last cut was at 3 and this was 0. And this right subproblem will be 3, 5, 7, 8 and 12. And this will be the partition that you'll be solving. This will be the ij and this will be the ij over here. Okay. Now if you carefully observe, if you're making a cut at 3, you'll be of 0, 1, 2, 3. And the length will be 3. So again, if you carefully see, 3 because that was the last cut and the last cut on the left was 0. So 3 minus 0 again gave you the length of the stick. Similarly, if you made a cut at 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so we just write this 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 is the length. And if you again take 12 and 3, you get the length as 9. Because this is the last portion where you made the cut and this is the right last portion where the cut was. So 12 minus 3 will give you 9. Imagine. I take this 5, 7, 8 and I say I will do a cut at 7. I'll do a cut at 7. So I will have a left guy as 3, 5, 7 and this will just be the partition that I'll be solving. I'll have the right guy as 7, 8, 12 and this is the partition that I'll be solving, I and j. Now if you're doing a cut at 7, you are hypothetically left with 3, 4, 5, 6, 7, which is a length of 4 and this is 7, 8, 9, 10, 11, 12. So just write it across 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5. So again if you see, 12 minus 7 gives you the length 5. 7 minus 3 gives you the length 4. So this is the reason j plus 1 and I minus 1. Because if you know the left last cut, right last cut, and if you just subtract it, you get the length. Yes, that is how you get easily the length. So I hope I was able to explain you why this and why the left subproblem and the right subproblem. Once you've understood this, I think this becomes a very simple cakewalk partition DP. So now what I'll do is I will just go back to the code. Okay, cost to cut a chocolate. And what are we given? We are basically given n the C, which is basically cuts of size C given an array. So this is the size C and this is N. Okay, perfect. So what's the first thing that we always do? Remember, this C is the size of the C. So we know the function that will be called will be for the partition of 1 to C, and we'll have the cuts. And this N is the length of the stick. So cuts dot push back is the length of the stick. Cuts dot push, or rather insert at the front, which is cuts dot begin. Right, please insert at the front, which will be 0. And you can just sort it. Cuts. To avoid complications, I have inserted these couple of guys so that we can easily get the length. Is because we know the first partition, the left partition initially will be at 0 and the right partition initially will be at n. That's why I have just inserted it. Make sure it is sorted, because that is something which you have proved. In order to make two sub problems independent, we have to sort it. Okay, so please make sure you sort it. And if we're using sort, we know we have to use hash includes. Please add hash include. Please add hash include. Done. Now let's write f int I int j, and you can write vector of int of and cuts. Perfect. And now what you'll do is, if this exceeds, you're going to return a 0. And mini, you can keep it as int max. Perfect. And any of the indexes can be from this till this and index plus plus. And the costing, okay, let's see if the constraints will, okay, 10 to the power 5, 10 to the power 3, even if I add up all of them, it still works. Cuts of this, cuts of this, perfect, plus the left one, which is I of index minus 1, cuts, plus the right one, which is index plus 1 comma j comma cuts. Perfect. And you can say mini equal to minimal of mini comma cost, and you can just return mini. Amazing. So that is how you will be doing this. Let's quickly check if you have done any mistake. I don't think so. Let's run this up and see if this is running fine. It does give me some issue. Okay, looks like we have, okay, over here we have an issue. Okay, it is giving me correct answer, and definitely this is recursion. This is recursion. So I have already taught you in all the previous lectures. If you are doing something as recursion, what is the time complexity? It's going to be exponential, because you're trying out all partitions, and that's going to take a lot of time. So in order to optimize this, there's only one way. Recursions, I've been teaching that throughout the entire DP playlist. Memoization. And how do you do memoization? You look at the changing parameters. We have one parameter as I, we have another parameter as j. So I can be from 1 to n, or rather 1 to the size of the cuts, and j can also be from 1 to cuts. So can I say the dp will be the size of the cuts, like the size of the cuts array, call it m. That's it. This will be the dp size. Just look at the changing parameter, have it on the dp, and write on the code. Over here you'll say dp of ij equal to whatever mini you make, and right over here you insert a line if this state has been previously visited. That's it. So if you just write these couple of lines, I think you should be able to solve this. So what I'll do is I'll just keep a vector int dp of definitely c+1 cuts vector int c+1 of -1. Amazing. Now you can just take this dp and just copy paste this, and you can say and of dp, and over here you can say dp of ij equal to this, and right over here you can say dp of ij is not equal to -1. You can return dp of ij. Amazing. So over here just make sure you pass dp, over here pass dp, and now you can just run this. So if you run this, this should be running fine. Yeah, this is. And if I submit this, you'll see this is giving you an accepted answer. I hope it does. It does. So what is the time complexity? Two changing variables of c+1 and c+1, c square and a for loop c cube. Yeah, two changing parameters will yield to n square number of states. Yeah, two changing, like if I discuss the time complexity, We just quickly write the time complexity. Two changing parameters I and j will give you n square or cut square m square into another looping variable which is near about m cube. Space complexity big O of m square for the array and auxiliary stack space. And I'm not interested in this stack space. So how do you optimize this? Tabulation. Tabulation is the way to optimize this. Yes, tabulation is the way. And how have I taught you tabulation? Copy the base case. Step 1. Copy the base case. Write down the changing parameters. In opposite. Copy the recurrence. So if I go and copy the base case, do I have a base case? I do have. What is the base case? Let's go back. It's I greater than 0. It's I greater than 0. It's 0 only. So instead of doing anything, what you can do is you can just declare a dp of c plus 1 and c plus 1 and make it entirely 0. Two changing variables. Where is I being called? Just go and look. You're calling it from 1 comma n. This is your I, this is your j. You're calling I from 1. This happens to go like this. So I will go from 1 to n in recursion. I will go from 1 to n in recursion. So in tabulation, it will be opposite because tabulation is bottom up. You take those bottom answers and you compute it. So n to 1. What will be j? J is going from n. Shrink. J is n to 1. So I'll take it from opposite. Just you have to write it in opposite. Make sure tabulation is writing in opposite. So take it from 1 to n. And then copy the recurrence as the last thing that you will do. So if you have followed the DP series entirely, you know this pattern. I've taught you how to make tabulation easy. So if you know this pattern, it's going to be a cakewalk stuff. Don't worry about that. So what I'll do is now I'll get back. Yeah, I'll get back to the code, and we'll keep everything as same. Just we'll make this as 0. Yeah, the DP will be 0, and let's write the same thing. So no base case. So the changing parameters will be written in opposite. So please make sure you write it in opposite, which is this, and then you write int j in opposite again, j lesser than equal to n and j plus plus. Perfect. You know the base case is this, which will be 0 always. So you can say this, we don't need to perform because already everything is assigned to 0. Copy every stuff over here. Copy the recurrence. I'll just copy paste the recurrence. See how easy it is. I just copy pasted the recurrence. I removed the return. Over here, dp of index plus 1 j. So yeah, that's what the first thing I'll do. Over here, dp of I of index minus 1. dp of I of index minus 1 is what I'll do. Okay, perfect. So what I've done is I've taken the left and the right, and I've taken this, and this will be dp of 1c. dp of 1c. Now something very important to understand. Over here, if j is at a moment taking index minus 1, and if I is n, it's still taking I plus 1, index plus 1. Okay, so n plus 1 might go n plus 1 as index. So this will be c plus 2. Just make sure for safety, take it c plus 2 because index plus 1 when I is n will tend to give you a runtime error. So if you've done this, try running this and you will see that this is indeed giving you the correct answer. Oh, it did not. Why it did not? Let's quickly check why it is giving you a runtime error. Because we've taken the cuts. Okay, by the way, it will not be n, my bad. It will be from c, and it will be from c because n is basically the size of the cuts array. So it will be very important that you take it till c. Okay, cool. Now it should be fine. Yeah, it is fine now. And if you submit this, it will give you the correct answer. Time complexity definitely n cube. Space complexity is definitely n square, where n is basically the cut size array, and there's no auxiliary stack space. So guys, I hope I was able to explain you this hard problem. So thank you guys for watching this video till the end. So just in case you have liked this video, please make sure you give a like to this. And if you're new to the channel, please do consider subscribing to us. And yeah, it is the season of appraisal. So what are you waiting for? Download the Hirect app from the link in the description. And yes, one more thing, you get 1,20,000 plus startups in the Hirect app, and there is no consultancies. So what are you waiting for? There's a link in the description. Make sure you download the Hirect app. Career hike karke to dekho. With this, let's wrap up this video. Bye bye. Take care.
Whenever your heart is broken.